Dear friends, in this video, I'm going to discuss business scenario questions on the conceptual framework of regression modeling that is part of predictive analytics for management, within brackets PAM. Let me begin the questions and discuss with you one by one. I am planning to give a separate video soon on interpretation involved in the regression modeling. Of course, the starting point is conceptual framework. Question 1. You are a marketing analyst. How would you use regression analysis to convince leadership about allocating more budget to social media campaigns? So, how do you justify more budget allocation to the social media campaigns? Naturally, it depends upon whether you are able to generate more sales or convert some of the prospective customers into real sales closure. So something like that. So how do you use this? Let's now look at the answer. So use regression to show a significant positive relationship between social media spend and sales conversions. A strong positive coefficient justifies more budget allocation. And that is what's called interpretation of the slope in the regression model. If the slope is positive with a strong value, to that extent, it shows you will be able to convert the sales into action if you spend more, and therefore the advertisement budget is justified. So this is the way you should convince the top management. So question 2. Your team presents two models with R squared is equal to 0.8 and adjusted R squared is equal to 0.76. Which one will you choose, and how would you explain your choice to a non-technical stakeholder? This is an interesting question. All of us sometimes get carried away by R squared, 0.8. Adjusted R squared in this case is 0.76. So the proportion variation explained by the predictor variable about y, the variation explained is 0.80. And more the value of R squared, greater is the veracity of the linear model that you have postulated. So theoretically, R squared can be 100%. It cannot be more than that. It's 100%. And it's a positive number. Now, what happens is when you add more variables, there is a tendency for R squared to zoom artificially. And therefore, you need to do adjustment for what's called the degrees of freedom. And the adjusted R squared becomes more important and paramount. So let me just give you the answer, having explained the background. While R squared is equal to 0.80 indicates a good model fit, adjusted R squared is equal to 0.76 considers the number of predictors. I would prefer, personally, the model with the adjusted R squared because it avoids overfitting. I would explain to stakeholders that adjusted R squared helps ensure only useful predictors are retained. And this is the answer for question 2. Now let's look at question 3. You are asked to verify assumptions of a sales forecast model, identify one key assumption of linear regression, and explain why it matters in real-world predictions. Very important. In the regression analysis, we are assuming, for example, one of the crucial assumptions. The errors are normally distributed, the errors are uncorrelated, and are normally distributed with mean 0 and constant variance sigma squared, let us say. One of the very crucial assumptions. And that is called homoscedasticity. You are assuming equal variance, constant variance. And that's very important for reliable predictions and forecast across the data range. Violations distort insights, especially for large value cases. So homoscedasticity, equal variance, this is a very, very crucial assumptions in sales forecast model based on linear regression. Let's now look at question 4. In a psychology study that uses multiple linear regression model, R squared is extremely low, which is a matter of concern. What will be your advice? Most of the studies in the behavioral science, the model need not be linear, first of all. It could be non-linear. That's my guess. Now let's look at the answer. When it is non-linear, the R squared is based on the linearity. Let's see now the answer. Look at the data carefully to diagnose if there is non-linear relationship. Explore building an appropriate non-linear model. That is the advice I would give. And in the case of the non-linear model, the R squared is calculated as 1 minus the error sum of squared by the total sum of squares. And therefore, the traditional one, total sum of squares, is equal to error plus treatment, is not the way we look at R squared for the non-linearity. Non-linearity, the R squared is calculated as, let me write it here, just insert a text box and simply write here. In non-linear regression model, R square is computed by the formula R square is equal to 1 minus, I open a square bracket, error sum of square, short form I write it as error, divided by TSS, total sum of square or total variation. And this is how it is calculated. And of course, the software will do that. And that's it. Thank you very much. We will see you soon in another video.